understand what we're doing today, you want to have in your or in front of you while you're watching this video. So make sure you have your memorized ion sheet and the abbreviations that explain this. These were notes that we took last week. So moving right on, what I'm going to do today is have everybody work in groups of 4. We're going to work in groups of 4 and recite to each other why reactions are what they are. Let me model for you. First of all, you know what the answers are for number 2, yes? What are they? Ox-red and SR, single replacement. So that's oxidation reduction and single replacement. What you're going to recite in your groups of 4 is this. And I'll explain the whole thing to you exactly the way I want you to recite it. This reaction number 2 is ox-red. The reason he's ox-red is because calcium is sitting here all alone. That means that calcium is an element. Now on this line, do you see an element anywhere else? H2. So that's going to be a 0. Now, what I'd like you to do is real quickly fill this in with me as I show you what we're doing here. And okay, what I'd like you to do along with me as you're watching this video is to fill in these things as we go. For the plus and the minus that you see next to calcium, so we're going to work calcium first. Now, calcium doesn't show a charge. So what is he? An element or an ion? Great. Okay, so if he's an element, he is atomic element number 20. If he's element number 20, how many protons will he have? Yes, he will. How many electrons will he have? Yes, so do it like this. Subtract the electrons from the protons. And so because he's an element, just like every other element on the periodic chart, they all have the same charge, which is 0. That makes an element. I'm trying to shake you by the shoulders a little bit to help you realize that everything on the periodic chart is an element, and as an element, until it reacts with something else, it is going to be a net 0. So let's do another one. No, we're just going to do 4 here. Oh, wait a second, we haven't done calcium the ion. Okay, let's do calcium the ion. How many protons will calcium the ion have? 20. If you tell me another number, it's not calcium. Calcium the ion and calcium the element both have to have 20. But now, how many electrons to get a 2 plus? 18. Good. So he lost 2 electrons, didn't he? Now, what's his net charge? Yeah, and that makes the ion. Okay? These guys are pretty simple to do, but the concept behind here is really important. I would say 90% of chemistry students never realize this. And I'm trying to shake you a little bit right now to help you understand the difference between an element and an ion. Okay, so let's go down, and next we're going to do oxygen. Okay, so for oxygen, how many electrons will oxygen, or how many protons will oxygen have? 8. Okay. And how many electrons will he have if it's the element? 8. Yes. So, there we go. We got the element. Now, what is the charge on oxygen as an ion? 2 minus. We know that because he's in which color? 16, yeah. Or column 6. And to get from column 6 into column 8, how many electrons do you need? 2 extras. Okay? So, how many electrons will oxygen the ion have? Huh? 10, yes. 10. Okay, so if we subtract 10 from 8, we come up with a negative number, don't we? And that's what we need for oxygen, and that makes us a 2 minus. And that is the ion. But this is the element. The electrons and the protons have to be equal if it's the element. And what you see here, let's point out all the elements on this whole sheet. This guy for sure, right? This guy's an element. Why? Because he's not with anybody else. Hey, do we have any other elements here? Oh, good. Potassium and oxygen. Do we have any more? Oh, magnesium. Where's the magnesium? Oh, yeah. Magnesium by himself. Good. Excellent. And we see oxygen, the element, don't we? What about bromine? Yes, he is definitely an element. Very good. And where else on this line? Chlorine. Excellent. So all of these guys are 0. So almost without exception, if you see an element in either a reactant or a product, you know that you've got a what? Change of what? Starts with a C. The charge change. And if it's charge change, what is it? It's oxyred. Yeah. Yeah. That's the oxyred dude. Okay, so this guy, that explains this being 0, and then over here, he's with another element. That means that electrons have been lost by the calcium. Okay? So, let's go back here and just do one more. Okay, let's get this down and this over. And now, phosphorus. Okay, what number is phosphorus on the periodic chart? 15? 15, okay. And protons? 15. Electrons? 15. Net charge? Because he's an element, you know that net charge has got to be 0. And now, let's do phosphorus again as the ion. Total number of protons? 15. Now, what do we have to have as electrons? Yeah, 18. That'll give us the 3 minus. I've never laid it out quite like this. This really works, doesn't it? And that gives us the ion. And I think that's enough, don't you? Okay, let's go back. So, this guy changed from 0. What is calcium when he forms an ion? He's in column 2, so he is 2 plus. Yes. And what is hydrogen's charge here? Yeah, 1 plus. Because he's in column 1. And what is he as the element? 0. Change of charge. So we have 2 things that change charge, don't we? We have the calcium and the hydrogen. Okay, so now why is he single replacement? Who gets replaced? Hydrogen, yes. Hydrogen gets replaced because he winds up over here all by himself. Oh, he gets 2, but it's just hydrogen. So there's no changing of electrons, no swapping of electrons. And calcium now is replacing hydrogen with the chlorine. Don't let this guy throw you. This is still chlorine. It's just in a different ratio. Remember that these reactions are happening with billions and billions of atoms. It's mass chaos inside. At least it seems that way. If you were looking at it, you would say mass chaos. But you can see atoms and molecules. Okay. So, it's oxred, because of the change in charge. It's single replacement because calcium replaces the hydrogen. Now, this is what I want you to do in groups of 4. And so that's going to be the end of the recording, and that's what we're all about today in the lesson.